The second module in the passive treatment example is the Ponds module. Ponds was created as a module to represent what are commonly referred to as settling or oxidation ponds or basins. Here is what the Ponds module looks like when it is first opened. Similar to the limestone bed module, the user should first enter the appropriate flow and water quality information for the mine discharge source in the water quality and flow input section at the top left side of the Ponds module. Please refer to the acidity calculator tool screenshot below for a list of the dissolved metals concentrations that were input into the calculator to calculate the net acidity of the raw mine drainage source, 85 milligrams per liter, that was used in the limestone bed module for input in the Ponds water quality information. The acidity calculator tool is accessible from the main user interface by clicking on the word Tools at the top of the screen. However, please note that the input water quality for the pond module should take into account that the incoming water will be the effluent from the limestone bed, so it will not be the same as the raw water quality of the mine drainage source. For our example, the water quality input for the Ponds module will assume that the iron and manganese concentrations remain unchanged in the limestone bed effluent, but the aluminum concentration was decreased by 75%, meaning 75% of the aluminum is no longer dissolved and either enters the pond as precipitate or remains in the limestone bed as solid. The next section of the module is sizing methods, focused on sizing the pond component. The first sizing option is labeled Oxidation, Settling, Sludge. This option allows the user to enter the depth for each layer of the pond, including freeboard, oxidation, settling or retention, and sludge capacity to size the pond, which is the method we will use for our example system. The other sizing option available is where the user specifies the top length and width dimensions of the freeboard layer. The freeboard layer is the top layer of the pond between the top of the water layer and top of the embankment, and typically contains an emergency spillway feature that is necessary to prevent breaching of the embankment due to flows in excess of the design flow or a problem with the water level control structure. A user would typically select to specify the freeboard top length and width dimensions in feet, where the pond is an existing feature and the user knows the dimensions, or where the land area available at the site is limited and the size of the pond must be constrained. Please note that if the user selects to manually enter the freeboard top length and width dimensions as the sizing option, the depths of each layer are still able to be manipulated, but the bottom length to width ratio in the next section is not. The next section, called System Properties, is similar to limestone bed, where the user can adjust the pond inside slope, the bottom length to width ratio of the settling retention layer, and the excavation unit cost. For our example, we will keep the default values for these three items. The next section is the pond layers. Note, under Pond Design, Oxidation, Settling, Sludge must be selected. Oxidation layer and sludge capacity layer are both optional layers in that the user may uncheck the box that is located within the drop-down for each layer. By default, both of these layers are included, and the boxes that make them active are checked, and both will be included in our example. The freeboard layer is the same as described in limestone bed, and we will accept the default value of 2 feet. The oxidation layer is the pond layer where metals are oxidized and precipitated, which overlies the settling retention layer where the precipitated metals settle out of the water column. For the settling retention layer, the user can specify both the depth and the retention time within this layer, which relates to the sizing of the pond. The optional sludge capacity layer is the bottom of the pond where the settled solids accumulate, forming sludge that must be periodically removed using one of the sludge handling and disposal methods to be discussed later in the annual cost input section. The final layer is where the user selects if a liner is desired and what type of liner material will be used, either clay, synthetic, or geosynthetic clay, including the option to use a non-woven geotextile separation fabric with the liner too, commonly used between the excavated ground and a synthetic liner. For the ponds component of the example system, we will accept the default values of the layers, except for the settling retention layer. We will change the retention time to 18 hours and adjust the depth of the sludge capacity layer to 1.5 feet. We have selected to use synthetic liner and the non-woven geotextile, but we must adjust the unit cost of the geotextile to match that used in the limestone bed of $3.50 per square yard. The hydraulic structure section is where the user specifies the piping, use of baffles, and any other appurtenances or other items needed for the ponds component. For the piping, the user can select to use either the AMDTreat piping calculator or a user-specified piping layout by checking the appropriate box with AMDTreat piping calculator selected by default. The AMDTreat piping calculator, which was selected for our example, and all default values used, includes 4 user-adjustable values for determining the cost to purchase and install the influent and effluent pipe for the pond. The user-specified piping layout simply requires the user to enter the custom pipe name, the length of pipe, and a unit cost for the purchase and installation of the pipe for 3 different types of pipe to be used in the pond. The next item is to select whether a baffle or curtain is required and whether to allow AMDTreat to estimate the length of baffle needed, or if the user will specify the baffle length. An AMDTreat estimated baffle length assumes 1 baffle, which is most commonly a floating vinyl curtain, will be used across the entire width of the pond at the approximate midpoint that is perpendicular to the incoming flow path and was selected for the example pond. Please note that the current default value of 5 is used for the baffle quantity per pond, and to adjust this value to 1, the user must first select user-specified length and change the value from 5 to 1, followed by then reselecting the estimate length to allow the software to estimate the length of 1 baffle. The appurtenances other items allow the user to include purchasing a pump for sludge handling, valves, an intake structure, flow distribution structure, water level control structure, and outlet protection structure for the pond by specifying the quantity and unit cost for each item. Please note that each item under appurtenances other items has a default quantity of 1, so if any item is not needed, the quantity must be changed to 0 or the unit cost set to 0. For the ponds example, neither a valve or intake structure is needed, so both quantities are changed to 0, and we will accept the default quantity and unit cost for the other items. The Other Capital Items section allows the user to specify any items that are needed as part of the pond construction that are not captured within the module, and allows the user to enter up to 5 different items, including a description, quantity, and unit cost. No other capital items are needed for the example pond. The Annual Cost Input section is where the user is able to specify items that affect sludge generation, sludge handling, and sludge disposal related to the ponds component. The first section, sludge generation, allows the user to manipulate parameters that affect the quantity and composition of sludge generated as well as the expected % solids of the raw sludge within the pond and the dewatered sludge following the handling process in preparation for disposal. Both calcite and miscellaneous solids can be estimated as contributors to the generation of sludge within the pond, both of which will remain 0 by default for our example. The settled sludge % solids for the pond's example will be adjusted to 3%. In the sludge handling section of Annual Cost Input, the user is able to define the method of how sludge will be removed from the pond, or select a generic unit cost for sludge handling and disposal as a composite for all removal and disposal methods if the method of sludge handling is not yet known. For our ponds example, and since we already selected to purchase a pump under the hydraulic structures section, we will choose the sludge removal by pump method by first selecting the detailed estimation instead of the default simplified estimation. For the sludge removal by pump method, we must indicate if running a pump using an electric or diesel fuel pump, and when selecting a fuel pump, we must specify the estimated fuel usage. The default is 2 gallons per hour, and fuel unit cost changed to $4 per gallon. If applicable, it is important to specify a mobilization/demobilization cost for a contractor to transport the necessary equipment to and from the site for each sludge handling event. For our example, we assume a $1,500 mobilization/demobilization cost per sludge event. The last item under annual cost input is sludge disposal. The first item to define is the dewatered percent solids expected for the sludge to be disposed. The default value is 40%, but for our example, we will reduce this value to 30% solids by weight. After defining the method for removing the sludge from the pond, sludge handling, to capture all of the annual costs for a pond, it is important to capture the cost to dispose of the sludge after it is removed and dewatered. If the dewatered sludge is to be taken to a landfill for disposal, there is a landfill tipping fee enabled to input the unit cost. But if this is not the disposal method, it can simply be unchecked, which will be the case for our example. For our example, we will use disposal by geotubes, and with that selection, we must review and adjust several parameters relevant to the use of geotubes. The first is to select the geotube size based on several standard sizes provided in a drop-down selection. By reviewing the module output information on the right side of the module under sizing summary, specifically for the line item thickened sludge volume, the user can see an estimate of the amount of sludge that will need to be removed annually. In reviewing this value under sizing summary, we can see the amount of thickened sludge volume is approximately 552 cubic yards per year, while the dewatered sludge volume is 55.2 cubic yards per year, and choose to select a geotube volume of 310 cubic yards from the drop-down options in order to provide about 5 years of dewatered sludge storage in one geotube. The default unit cost for the geotube is applied based on the costs provided by the manufacturer, but can be adjusted as needed. The other two variables that may need adjustment when geotubes are selected are the expected time to excavate, haul, and dispose of each truckload of sludge, and the round-trip distance the truck must haul the sludge for disposal from the geotube. For our pond feature, we will estimate these two values to be 30 minutes and 3 miles, respectively. All other default values will be used and no other annual items will be included. The pond sizing summary on the top right side of the module provides a wealth of information about the pond component based on the user input from the right side of the module. From the various layer dimensions to the surface area, total pond depth, volume, and retention time of each layer, the length of baffles needed, the volume of thickened and dewatered sludge, and the frequency of sludge removal based on the sludge capacity layer volume and thickened sludge volume. The total retention time of the pond, including all 3 water-containing layers, is 39.59 hours. Oxidation, settling, retention, and sludge capacity layers, and the total depth is 6.5 feet. The estimated freeboard top length and width values are 134.04 feet and 77.02 feet respectively. The capital cost section summarizes each of the primary components for the pond feature and provides a total cost to construct the pond based on the user-specified features and sizing criteria. The capital cost of the pond is estimated to be $41,832. The annual cost section includes the costs associated with the operations and maintenance, sludge handling, and sludge disposal for the pond. For each of these 3 items, the user can accept the default estimated values from the module or input known values for any of them where appropriate. For the operation and maintenance, we will change the percentage of capital cost value to 5%, which results in a total annual cost of the pond to be $6,983. Finally, the NPV for the pond feature is $274,072 to maintain it for a 75-year period. That concludes the ponds module portion of the tutorial. Next, we will discuss and examine the wetland module in the passive treatment tutorial entitled Passive Treatment Module 3 Wetland. Thank you, and please refer to the module tooltips and online help files for additional information.